Hey, what's up, everyone? This is Group 2. Our project is going to be on digital marketing analysis for business to customer retail. My name is Kevin Chang. I'm in the MSBA program, and I have two partners with me, and they are Pauline Chen and Amber Sai. Pauline is in the MSIS program, and Amber is in the MBA program, and all three of us are going to be graduating at the end of next semester. For this presentation, Amber will be covering the business problem and data collection, Pauline will be covering the data cleaning, and I'll be covering the EDA and linear regression. Pauline will be covering the clustering analysis, and I'll be covering the logistic regression model and results interpretations. And with that being said, I'll let Amber start off with the business problem.
The business problem we are solving for is, are we able to predict which customers are more likely to make a purchase based on their interactions with certain marketing campaigns, especially by digital channel? By identifying the demographics and behaviors of high-intent customers, we will be able to advise the marketing team on where to apply their budget to target the right customers with a higher chance of purchasing. This will allow the business to drive more sales while allocating their resources more efficiently. We chose this Kaggle dataset because it mimicked the digital marketing campaign data one would see in real life. It was also available in a CSV format, making it easy for us to work with. With a high number of rows, key marketing and engagement variables, as well as historical variables, we were given a wide range of data points to analyze. This chart is a quick overview of the data points we were given in the dataset. We have categorized these into four major categories: demographic, marketing engagement, customer engagement, and historical purchase behavior. The types of analyses we decided to run are regression analysis to look into correlation versus causation. We wanted to know, do customers in higher income brackets tend to spend more or even have more repeat purchases? We also applied clustering analysis for segmentation by demographic and psychographic variables. Lastly, we ran logistic regression models to identify the effectiveness of ad channels. Before we could begin our analysis, we had to first clean the dataset by creating buckets to standardize age groups, gender, and income levels for more accurate correlation analyses. Also, it is important to note that these causal analyses we're running will not take into account any future macroeconomic conditions, which may affect buyer behavior.
Before starting analysis on the data, we conducted some data cleaning and feature engineering. First, we converted the data types as needed and validated the age and income ranges. We also standardized and normalized the data and ensured consistent formatting. Next, we got rid of any duplicates based on the customer ID. Then, for more data preparation, we computed the engagement score from pages per visit, time on site, social shares, email opens, and email clicks, and weighted them. We also created age buckets by generation and income buckets to arrange. Finally, we saved all the data preparation in a new data file and began our analysis.
Alright, I'm going to be discussing some of the basic EDA that we performed for this project. For this project, we started off with some basic summary statistics and also some basic plots, which we're not going to show for this presentation since we already did it for a proposal. Those types of summary statistics are typically used as just like preliminary understanding for the data. So the two topics that I did want to talk about for this presentation were our correlation matrix between the different variables and also a plot of conversion rate by campaign channel. Alright, so the table on the left is a correlation matrix, and the purpose of a correlation matrix is that it allows the users to understand how the data variables are related to one another. This is important because we don't want any of our variables to have multicollinearity when we're setting up the models, because variables that are multicollinear are typically regarded as the same when it comes to linear or logistic modeling. Now, in order to interpret the correlation matrix, we can see that the darker colors mean that there's a stronger correlation between two variables. For example, email opens and email clicks are dark blue, so that means they have a real positive linear multicollinear relationship. So that means that we should probably pick one of those variables when it comes to our models. Now, the second model on the right is a graph of a conversion rate by campaign channel. And we originally did that because we're considering media mix modeling, which is selecting specific digital marketing channels to focus on. Except from this plot, we can see that almost all the different campaign channels have a similar conversion rate. And another reason why we chose to do this plot is because the data set that we have from Kaggle, it wasn't clear whether or not a 0 or a 1 for conversion meant whether or not it converted or not. So based on this, we were confirmed that a 1 means that it's a positive conversion. Alright, so we start off with linear modeling. And we ran this twice. The first time around that we did it was just a preliminary sort of experiment, and the second time around was more of a fine-tuned version. So first time around that we did linear modeling, we used all available variables in order to try to determine whether or not a customer would convert or not. And the available variables were age, gender, income, ad spend, time on site, social shares, email opens, email clicks, website visits, and pages per visit. And from this model, we got a sort of mediocre R-squared score of around 0.08, which means that there could be multicollinearity or other fine-tuning that we had to do for this sort of model. Alright, so the second image on the right is a refined linear model, and for this model, we use ad spend, time on site, email opens, email clicks, website visits, and pages per visit to try to predict whether or not a customer will convert. And the reason why we dropped some of the variables from the first model is because they had low p-values. So even after doing the refinement on this model, we saw there's still a pretty low R-squared score of 0.08, and ideally the R-squared score in a real-life data scenario should be around 0.2 to 0.4. So this led us to believe that we should probably explore clustering or logistic regression. So for our next topic, Pauline will be talking about our clustering model.
For our k-means, we chose k equals 3 based on several considerations. First is that we use the elbow method. In our analysis, the plot suggested that after 3 clusters, the reduction in WSS diminished, indicating that the additional clusters might not capture significantly more structure in the data. Second reason was for its interpretability. With 3 clusters, it becomes easier to interpret and profile distinct groups of customer behavior. This allows for actionable segmentations where each group can be described and targeted with tailored marketing strategies. Finally, there's a balance, as using fewer clusters like 2 might oversimplify customer differences, while too many clusters could result in overfitting and making it difficult to draw clear business insights. Moving on, the silhouette plot from the analysis shows that there's an overlap of clusters, as many points are near the boundary between 2 or more clusters, suggesting that these customers exhibit behaviors that straddle different engagement patterns. The silhouette plot also suggests moderate separation, since these clusters do capture some differences in engagement and conversion behaviors, but there is overlap. Therefore, to identify these high-intent clusters further, we look beyond the silhouette plot and examine each cluster's average engagement and purchase-related metrics by analyzing the cluster summaries. So, if we recall, our end goal for our business objective is to have more efficient resource allocation and prevent wasting ad expenditures on low-intent customers. Therefore, we need to analyze the cluster summaries to find these as well. So in this chart, we highlighted the highest means between the 3 clusters and see what we found. We summarize the key observations from the cluster summaries chart. First, the high intent cluster was cluster 1. It has the highest overall conversion rate and is strong across multiple engagement channels. It also had the highest overall engagement score, which suggests a well-rounded, deeply involved group. Therefore, we suggest cluster 1 to be the primary target for ad expenditure and consistent brand messaging. Next, the moderate intent group is cluster 3. Its conversion rate is close to cluster 1, but it's slightly lower, and they spend the most time on site, which may indicate a need for more information or decision support before purchasing. Therefore, the marketing implication would be to provide detailed product information to push them over the line. Finally, the low intent cluster is cluster 2. It had the lowest conversion rate despite the highest click-through rate. This means that they are quick to click but less likely to finalize a purchase. Their lowest engagement score also suggests a shallower level of overall involvement. Therefore, if conversions remain low for cluster 2, we should shift spending towards high-intent clusters. And with this cluster summary, it is clear to focus on cluster 1 for immediate ROI because of its high conversion and broad engagement. And by focusing on this cluster, we will reduce wasted ad expenditures and increase ROI on digital campaigns.
Alright, so I'll be talking about our logistic regression model and some of the key takeaways that we had. So overall, we predicted conversion pretty well using several predictors, which were ad spend, time on site, email opens, email clicks, website visits, and pages per visit. And we had a deviance and a AIC score of 4,787 and a residual deviance of 4,196. And based on the confusion matrix, we could see that there was very few true positive values, except our model was still able to detect them pretty well. About 87% customers made a purchase, and our model was about 88% accurate with 99.7% specificity and a positive predictive value of 69% and negative predictive value of 88%. So I guess it performed pretty well. And here's a visual of our ROC curve as well as an AUC score, which we can see is 0.691. Typically, a good ROC curve will be very close to the left corner, so you can see that our curve isn't really as sharp, except it still performed moderately well. Our AUC score is 0.691, and that is a pretty acceptable score. Ideally, it should be higher, except due to how much our data was skewed in terms of the proportion of positives and negatives for conversion. Otherwise, I could say our model did pretty well. We could summarize our logistic regression model with 3 key points. The first one was that significant predictors show that customer interactions with marketing campaigns are indeed related to conversion likelihood, or that customers who engage with more digital channels are more likely to make a purchase. The second point is that engagement metrics, such as email opens, email clicks, time on site, and website visits, are strong predictors of conversion, and this implies that customers exhibiting these behaviors on digital platforms are high-intent customers. The third point is that the high specificity indicates that when the model predicts conversion, it's almost always correct, and this is useful for ruling out customers who are unlikely to convert, which allows marketers to avoid spending on them. So from our overall project, we got 3 main points that we learned from this project. The first one was that from our EDA and preliminary data linear modeling, we found that other models, such as clustering and logistic regression, will fit better for answering the question whether or not a customer will convert. The second point that we had was that from clustering, we were able to separate our data into 3 individual clusters based on how likely they were to convert. And the third point that we got was that using logistic regression, we were able to create a moderately strong model that could identify potential converters. Alright, this brings us to the end of our video. We hope you enjoyed watching it. Hopefully you learned something. If you have any comments, questions, thoughts, or concerns, please let us know in the comments. And thank you for your time. See you guys around.